Welcome, everybody, to the latest episode of Star Cells and God. This is the show where we discuss new discoveries taking place at the frontiers of science and discuss how these discoveries provide evidence for God's existence, His character, and the reliability of Scripture. My name is Fuz Rana. I am a biochemist and a Christian apologist, and I am joined in studio by Dr. Hugh Ross, who is also a Christian apologist and an astronomer. And we both work for an organization called Reasons to Believe, www.reasons.org. Go to our website, check us out if you want to know more about RTB. Also, follow us on social media, RTB_official. And then last but not least, please go to our YouTube channel, Reasons to Believe, and subscribe to our channel. There you'll get all kinds of great content that gives you information about the science-faith dialogue. Also, make sure you hit the reminder button, the notification button, so that you will be alerted the next time an episode of Star Cells and God drops, which is every Thursday. Hugh, today we're going to be talking about alien spacecraft and synthetic embryos. So,
fantastic. All right.
So, Hugh, why don't you go ahead and get us started?
Well, this is an unusual kind of discovery, and it's a lot of people in our constituents been saying, please do a Star Cells and God on this. And the so-called discovery is the fact that different governments are saying, and particularly the U.S. government, that we have physical evidence of alien spacecraft that have visited here on planet Earth from other planetary systems. Now, this is not new. These claims have been going on for a long time about what's on the internet is all these articles basically saying that the U.S. government is now actually admitting they got real physical evidence. And so because we made the claim in this book, Lights in the Sky and Little Green Men, that this physical evidence is non-existent and not credible, we have been asked to respond. So I'm going to give 3 reasons why this is not credible. And the first reason is that they're overestimating the capacity of our U.S. government or any government in the world, for example, of being capable of covering up that kind of physical evidence for several decades. Because the claims are such as, in Roswell, there's a special government hangar where they got under wraps a big alien spacecraft there that they're hiding from the public. Other stories is something's going on in Area 51 or something in China Lake or some other government base where this is covered up. And people are now claiming that it's not just one spacecraft, but several. So physical artifacts of several spacecraft. And so I brought one of these with me today. Do you remember what these are, Fuzz?
I do. I sure do.
So you're old enough to remember these little cassette tapes. And the ministry started Reasons to Believe, or we were distributing these little cassette tapes of messages that we're giving to different university and church audiences. Well, the reason I brought this cassette tape with me is that back in the Nixon era, President Nixon tried to hide just one of these audio cassette tapes from the public. Now, he had all the power of the executive branch behind him. He had his whole team people saying, we got to keep this from going public. You know how long he was able to cover up a single audio cassette tape? Just 11 days. 11 days he could no longer keep this secret away from the public. So the idea that there's like a 50-foot or 100-foot diameter physical spacecraft in some secret hangar that's been covered up from the public for 50 years and not a single piece of physical evidence has come out, it's not credible. I mean, one of the co-authors we had for Lights in the Sky and Little Green Men was Dr. Mark Clark. He wrote 2 chapters in the book. And the reason why Ken Samples and I recruited him is that he's one of the foremost national security experts in the country. He's a professor at Cal State, California, and San Bernardino, and actually heads up an 8-university coalition where they're basically doing research on government and military intelligence and security. And so he basically said, I know from personal experience, the U.S. government does not have a security system adequate to cover up physical evidence of alien spacecraft for more than a year, for more than a week for that matter, let alone a year or decades.
I mean, you would think that somebody, if they saw a craft like that, in government control, given the magnitude of what that means, would probably leak that. It's hard to imagine nobody leaking that information.
Right. As Dr. Mark Clark was pointing out to me, even if this was Soviet military security, which is considered to be in the Cold War, the ultimate government security, he says even they would not be able to cover up something of that nature. Somebody would leak it out, an artifact would come out, something that you could put in your hand, something. Now, there are fuzzy photographs, but fuzzy photographs are not, scientists don't look at that as physical evidence. They can easily be concocted. There's lots of fuzzy photographs. People even produce fuzzy photographs of bodies of UFO beings, but there's no physical evidence of either a UFO being or their spacecraft. And this slide that I got next here basically shows a lunar rock. And, I've actually been to different museums where I've seen these rocks. I've been in different research labs where scientists actually had a rock. Of course, I wasn't allowed to touch it because you don't want to contaminate it.
Right.
But these rocks are and they appear in the scientific literature. People have analyzed them. Notice there's not a single research paper in the scientific literature that gives any credence to a physical artifact from an alien craft. So there's nothing in the scientific literature, nothing in a museum, nothing that any scientists or public figures come forward and said, hey, this is a piece of something from an alien spacecraft. Forget about producing something 50 or 100 feet in diameter. Just show me something that's a centimeter across. Nothing like that has ever been produced.
Not that we want to get sidetracked with this controversy, but when people claim that we never went to the moon, the fact that we actually have lunar rocks that were retrieved on the moon and brought back to Earth and are available for the scientific community at large to study and are on display is physical evidence that indeed we went to the moon.
It is, and notice there's been research papers published on lunar rocks for the past 50 years. It's not just a brief episode. Even recently I wrote an article for our blog, The Reasons to Believe, blogs that we produce, about the latest research on lunar rocks. So even though they were recovered in 69, 70, 71, they're still doing research on it. Nothing like that for the alien spacecraft whatsoever. Now, the third reason, and I think this is the most compelling reason of all, is it simply would be a violation of the laws of physics for a physical spacecraft to go from one planetary system to another planetary system. And this has actually caught the attention of astronomers who would like to study what's going on the nearest planet outside of our solar system. It's a planet that's orbiting the nearest star, Alpha, or it's Proxima Centauri. One of the stars is orbiting the Alpha Centauri system. And so it's only 4.25 light years away, which means it's close enough. It's actually realistic. We could send a spacecraft there. But they recognize, with 4.25 light years, we're going to have to go reasonably fast to get there. And anything that,
Right.
you want to get there within the lifetime of an astrophysicist, right?
Yeah.
And so the plan is, well, let's send that spacecraft at 10% the velocity of light, maybe 20% the velocity of light. But the recognition is, you got the problem of E equals mc squared. And I throw that equation out, Fuz, because I notice every person in the world virtually knows that equation. They don't know any other physics equations, but they know that one. It basically is saying that the energy that you get from matter goes up with the square of the velocity. C squared is the velocity of light. So it means the faster you travel through interstellar space, the more damage you'll do to your spacecraft. In fact, even the protons you encounter, the neutrons you encounter, will do significant damage to your spacecraft. Even the electrons will. Dust particles would be far more damaging. And so the recognition we can't go very fast. Astronomers are saying, let's keep it at 10% the velocity of light. That means it's going to take 42 years to make a one-way trip. But hey, some astronomers are able to do research for more than 4 decades. So they said, fine, we'll take 42 years to get there.
And then if you're able to communicate information back, that's still another 4.5 years.
So we're actually looking at 84 years to get any meaningful information back from the spacecraft, which is why some astronomers are saying, I think we need to go 20% the velocity of light.
Right.
So if you go that fast, then you cut the time down by a factor of 2.
Mm-hmm.
So, however, there's a recognition maybe we can't go 20% because at 20%, you get 4 times the damage to your spacecraft that you get at 10%. Well, the recognition is even at 10%, we're not able to send a spacecraft bigger than 10 centimeters across. Because again, the bigger the spaceship, the greater the cross-section. The greater the cross-section, the more impacts you're going to get. And so to minimize the damage of the spacecraft, they're making the spacecraft small. And the calculations show that you don't want to go beyond 10 centimeters. And at 10 centimeters, you're going to need to send 1,000 spaceships to the nearest planet, because at least half of them will be destroyed before they get there. The remainder will be partly destroyed, but they'll be partly destroyed in different ways. And so the hope is maybe they can, out of the 1,000, they get 400 that are able to function to some degree, and they get some meaningful information back about that planet. So this is a serious proposal by the astronomical community. And hey, if we're talking spacecraft that tiny, they're going to be relatively cheap. So making 1,000 of them is not out of the question. Let's go to that planet. But it's basically making the point. For you and I to travel to that planet is out of the question.
Yeah.
Because now we're going to need a spaceship big enough to keep us alive for 40 years. And it's got to be a lot bigger than 50 feet because somehow you got to protect us from the radiation. And so it's basically making the point, no large physical spacecraft can make the journey from even the nearest planet. And we already know that nearest planet is not habitable. So if you're talking a habitable planet, we're looking at least hundreds of light years away. And now you're looking at a travel time from that planetary system to our system that's calculated to be greater than the maximum time a civilization can maintain technology at the level we're enjoying here on planet Earth today. And so, and that's something we talked about in this book, Lights in the Sky and Little Green Men, is that if we're talking physical beings traveling to us in physical craft, the laws of physics rule that out. Now, we're talking about beings like angels that are not subject to the laws of physics or these problems that we're encountering. That's a different issue. But if we're talking any life form or any spacecraft that is limited by the dimensions and laws of physics, it simply can't make here. So I would consider that to be the most compelling reason why these dozens of stories on the internet that have popped up in the last couple of months simply aren't credible. They can't produce any evidence. The government security isn't adequate to the task, and the laws of physics make it impossible for any physical craft of that nature to travel that distance.
Yeah, and this may or may not be a fair question, but I've been reading a lot about the work of A.V. Loeb, an astronomer at Harvard University, chairman of the department. So he's definitely someone who's extremely credible.
Yes.
And is of the opinion that this really unusual asteroid that went through our system, Oumuamua or something.
Yeah, it's got a complicated name.
Yeah, was perhaps an alien, an alien spacecraft. And he makes an argument for why he thinks that's the case. And I know it's highly controversial, but even he who's suggesting that there might be an area of astrobiology called astroarchaeology, where we look for maybe artifacts that alien civilizations might have sent our way as a way to, probe for the possibility of advanced civilization. So he's arguing, well, this might be comparable to the probe that just left our solar system, the Voyager 1.
Voyager, right.
Yeah. Voyager 1, Voyager 2, I think both have left our solar system now. So so I guess my point is that it's important for people not to take his credibility and what he's claiming with his work and conflate that as evidence that there are these extraterrestrials that have actually visited Earth, because he's arguing something very different than that.
He is, and I've read his papers in the peer-reviewed literature, and he's basically referring to this asteroid that we have seen come into the solar system, and he says its shape is unusual. It's almost pencil-shaped.
Right.
And he's basically saying that's highly unusual shape for an asteroid or a comet to take, particularly a comet, which is basically frozen volatiles. You'd never expect it to take that kind of a shape, which is why I'm saying I think it's an asteroid. And asteroids are reasonably rare in the outer part of the solar system, ones that are made out of solid rocky material. So he's arguing based on the shape. But he does say in his paper, I'm not claiming that this is impossible from a naturalistic perspective. And there's been over a dozen articles in the peer-reviewed literature, basically, and all of them are refuting his claim.
Right.
But he says, this is a possible.
Right.
He says, we need to consider the possibility. Right. And also, he was making the claim, I'm not suggesting that this has life forms on it.
Right.
That it was a probe sent out, again, kind of like Voyager. Voyager has left the solar system now. Who knows where it's going to go? And yes, somebody might encounter it, but it was never our intent to send a life form to a planetary system. Right. So it's in a different category.
Right.
And people have also been claiming that Tabby star is evidence of an alien civilization. And this is a star where we've seen significant light variations in the star, literally dimming by as much as 20%. Mm-hmm. And so people have been speculating maybe there's a Dyson sphere around that star. A Dyson sphere is where a very advanced intelligent civilization basically puts a metal sphere or a silicon type sphere around a star and basically uses it to draw energy from that star. I mean, you can imagine we could build some spherical or partly spherical thing around our star, the sun, and to make it all solar panels. And so the solar panels would be drawing energy from the sun, converting that into electricity, sending it down to Earth, and we'd have huge amounts of electrical energy. And so Freeman Dyson speculated decades ago that a really advanced civilization could do that. Well, this team held it up by this astronomer with the name of Tabitha. She was basically saying, well, maybe that explains these observations. Mm. And hey, there's an article at reasons.org that I've written that basically says that another astronomer made the point, if you've got a planet moon system like ours, a rocky planet with a big moon orbiting it, says number one, it'd be rare because it can only happen if two rocky planets collide. That's how our moon formed. But he says, unlike our moon, the mathematics shows us that it's very likely that that moon will collide with a planet. It either spirals away and becomes dissociated from the planet, which case it shares the same orbit around the star as a planet and is inevitable it's going to collide. Or it begins to spiral away and it comes back and hits the planet. When it hits the planet, you get this huge dust cloud. That dust cloud is not going to be evenly distributed in the planetary system, and that easily explains the dimming effects that you see. And other astronomers have said, well, there's other ways too, where you can get big, thick dust clouds in a planetary system that explain it. And so, again, when you see a claim like this in the scientific literature, let alone on the web, read what everybody else says about it.
Right.
So you got this, single paper saying, hey, maybe a Dyson sphere, and you got a dozen papers saying, no way, this can be naturally explained.
But I think the key point, though, is even when people are making these kinds of claims, they are presenting an argument that's going into the peer-reviewed literature that then is put in harm's way.
Right.
It's evaluated, and the evidence is openly presented,
And, people like A.V. Loeb and others, they're basically challenging the astronomers. Hey, it would be valuable if you could prove that this is wrong. And so a no answer is considered to be just as valuable as a yes answer. And it's like, hey, it'd be interesting if we can actually prove this is incorrect. And so when astronomers put something out like, they're actually inviting critique.
Right.
Let's look at this and see if this has any credibility.
Yeah.
Okay. Hey, what do you got on
Well,
biochemistry? I mean,
I'm going to talk about synthetic embryos. But to kind of set the stage, I was going to tell a little bit of a quick story. I learned to drive when I was in high school, like many people. And back in those days, I don't know if this is still the case because of liability issues, but back in those days, you could actually take a driver's ed course at the high school that was part of the high school curriculum.
mm-hmm.
And it was a semester course where there was an in-class session and then, a practical session where you're out driving a vehicle. I still carry a lot of lessons from that driver's ed class with me today. Some of them have to do with driving, but others are actually life lessons. And one of those life lessons that I learned is not to overdrive your headlights.
Okay.
Right. And I think most people are familiar with this problem. But if you're driving at night and the rate of speed is greater than the distance, or the rate of speed is so great that the stopping distance is greater than the distance that the headlights are illuminating, you actually are driving blind.
Yeah.
There's and that could lead to a catastrophe.
Well, I see you got a human being there.
Yeah.
That's at a risk of you
yes.
doing some significant damage to.
Right. So the point is you don't want to, overdrive your headlights. That's just auto safety. But it actually is a good life lesson as well, that you want to make sure that in life, as much as you can, that you're not going so fast, towards some kind of goal that you don't pause to take an assessment of your circumstances, to think through what might be some possible outcomes. How are you going to respond to those different outcomes?
Hey, Fuz, that's an important lesson that I learned when I started climbing mountains. You don't want to climb them so fast that you miss the dangers that are in the way.
Yeah.
Like suddenly there's a ravine there.
Yeah. Right. Well, again, it's a principle that's extremely valuable. It doesn't mean that you're never going to be surprised, but it means that you're less likely to be surprised. And if something, unforeseen happens, you've at least thought through some scenarios. Well, this is also really a lesson that I think the scientific and the technology communities could take to heart, because we are at a point now where scientific advance is happening exponentially. And it almost feels to me like the technological advances that are coming from scientific insights are progressing even at a greater exponential rate. I don't have any evidence to prove that's the case, but it just feels that way, to the point where we are, developing technologies at such a rate that we don't have time to even reflect upon what the technology is, to understand it, to think through how should we use it, or should we even use it?
The ethical issues.
Right.
Yeah.
Right. And other broader issues beyond ethics, safety, and things like that.
Economy.
Yeah.
So.
And here's a great statement I found from Alan Lightman, who's a physicist and also a novelist as well.
Yeah, he's a great author.
Yeah.
So.
But he says this: I have no opposition at all to technology. I think technology is a wonderful thing that has to be used thoughtfully. And we can't just assume that every bit of new technology improves the quality of life. It's really in how the technology is used. What I'm very disturbed about is this trend of everything happening faster and faster and faster, and there being more and more general noise in the world and less time for quiet reflection on who we are and where we're going.
Wow.
Powerful quote that, again, is reminding us, let's not overdrive our headlights. Well, I think there's a place where we are, if we've not overdriven our headlights, we're dangerously close to doing that in one area of biotechnology, and this is the creation of synthetic embryos. And this is a headline taken from last summer.
And we're not just talking embryos of bacteria or fungi.
No, these are synthetic mammalian embryos.
Wow.
This is a headline from last summer, Scientists from University of Cambridge claimed to have developed, and they did actually, not claim, a synthetic mouse embryo with a developing brain and a beating heart grown from stem cells. So this is an embryo not produced through in vitro fertilization from an egg and a sperm. It was produced from a single cell, an embryonic stem cell.
We're talking in the lab,
Yes.
not inside a mammal.
No, this is in a lab setting.
Yeah.
And then just about a month ago, there was an article published. Well, these articles were published all over the internet, where scientists from the Chinese Academy of Science presented evidence that they had made a monkey synthetic embryo. So we're progressing from a mouse to a monkey. And while I was preparing for this recording,
okay,
just a few days ago, the same team from the University of Cambridge now claims they made a synthetic human embryo in the lab. Now, this has not been published. This has been presented. This was data that they presented at a scientific meeting, and an article was written about it. So there's nothing that's been peer-reviewed or even a preprint available.
But it was presented in front of their peers.
And this is the same team that did the work on the mouse embryo. So I believe this is probably an authentic result. And so this is a place where we are developing biotechnologies in this particular case, the creation of synthetic embryos. This is 9 months. This is, in the span of 9 months. And we're not able to spend the time to properly think through even what is this technology and, what are the ethical implications of this technology before the next advance and the next advance and the next advance are happening.
I don't know about you, but when I was in high school, we were required to read the novel 1984.
Yeah.
And I remember the literature teacher saying, there's no way this can happen, anything previous to 2084. Well, maybe 2024. I mean, look how close we are to having artificial wombs.
Yeah.
So
well, so this is, again, raises a lot of questions. And so one of the things I just want to talk about is really how should we think about this as Christians, and how should we engage our culture and the scientific and the technological communities, with respect to this kind of work.
Okay, one question, Fuz. How far developed was this human embryo?
That I don't know the answer to.
Okay.
But we can. What I was going to do is talk a little bit about what a synthetic embryo is.
Okay.
Because I don't think a lot of people understand what it is precisely. And even when you understand what it is, it doesn't necessarily make the ethical deliberation easier. It actually adds to the complexity. And then why would people even want to do this, right? And then what should our response be? And a little background would be helpful, I think. This is showing the process of very early embryogenesis, where you have a fertilized egg, and that fertilized egg then is actually surrounded by a membrane called the zona pellucida. And once the fertilization takes place, the egg cell doesn't grow, but it just starts to undergo what's called cleavage,
right?
Where it goes into a 2-cell, 4-cell, 8-cell stage. And then eventually you're at the 16, 32-cell stage, where it's referred to as a morula, which is referring to its blackberry type appearance. This is when things get interesting, because eventually that zona pellucida dissolves away, and it's replaced by a single layer of cells that are referred to as the trophoblast. This is going to become the placenta when the embryo implants in the uterine wall. And then you have what's called a blastula, where you have cells that are called the inner cell mass that are going to wind up developing into the organism. And again, they're surrounded by the trophoblast. And then you have a process that begins called gastrulation, where you now start to get an invagination of the blastula, and through that process end up creating different cell layers that are going to be fated to develop into that into an adult form. This is another
stage.
Well, this is actually showing again the blastula. Yeah, the blastula, where you see the outer cells. That's the trophoblast. That's going to become the placenta, and then the inner cell mass, and then you have the endometrium, which is the lining of the uterine wall where the embryo will implant and begin the process of embryonic development in the uterus. Here's showing what happens during gastrulation. So again, you have the blastula, and you see that there is a region that undergoes this invagination, and that creates what's called the primitive gut, the archenteron, and then that eventually is going to become called the blastopore, which is the opening into this primitive gut, which is called the blastocele. And you can see now that there are two layers. This is two layers independent of the trophoblast, an ectoderm and an endoderm. And then later, parts of the endoderm develop into a layer called a mesoderm. And it turns out that cells that are in the ectoderm are going to wind up developing into the nervous system and into the epidermis. Cells that are in the mesoderm will develop into muscles, into the skeletal system, blood vessels, and then the epidermis, not the epidermis, but the dermis of the skin. And then the endoderm are cells that will end up developing into the digestive system, the respiratory system, and then other organs like the liver, the pancreas, things like that. And then the next stage in development, which I'm not showing here, is called organogenesis, where now those cell layers start to develop into those organ systems. And that's the process of organogenesis or organogenesis. This is another slide, again, as part of background information to show what an embryonic stem cell is. These are cells that are isolated from embryos that are produced through in vitro fertilization, where you'll get the development to essentially the blastula stage, and then you break apart the embryo and you isolate the inner cell mass, you discard the trophoblast. And the idea here with respect to doing this is that these the cells that are part of the inner cell mass, they're called blastomeres or embryonic stem cells, have the developmental potential to transform into any of the 210 cell types in the human body. So people are exploring ways in the lab that they can culture those cells to get them to develop into progenitor cells or into cells, cardiac cells, nerve cells, things like that. People are even looking at creating organoids, where you create three-dimensional cell cultures. So this is, again, background information. So what these scientists are doing when they're creating a synthetic embryo is they are foregoing the fertilization process. They're starting with embryonic stem cells. This is a diagram showing what the scientists did from University of Cambridge with regard to the mouse synthetic embryo. In this case, they actually took cells from the trophoblast as well as the stem cells, and then there was another cell type that they used as well, and they isolated them, they cultured them separately, and then they intermingled them into this aggregation stage, and then they put them into these very complex bioreactors that allowed them to develop into these three-dimensional cell cultures that essentially were synthetic embryos. So that instead of starting with an egg cell and a sperm cell, they started with an embryonic stem cell, and to get it to develop into these embryos.
This is a single stem cell, not a multiplicity?
Yeah.
So they get it really early then?
Yes. Yeah. The success rate for this isn't the greatest, right? It's a pretty low success rate, but they're able to do it. And in fact—
And by low, we're talking less than 1%?
Yeah, thereabouts.
Yeah, okay.
But the fact that they're even able to do that consistently is remarkable. And now, and what they were able to do in mice, the gestation period of mice is 22 days. they were able to get the embryos to survive for 8 days. That's where you saw less than 1% success, is going to the 8-day stage. There's greater success, for the earlier processes of development.
Right.
But in a mouse at the 8-day stage, you start seeing a primitive brain, you start seeing other primitive organ systems. And so this is remarkable that this is all done in vitro, right? That they're able to accomplish this thing. And so the question then is, why are people interested in doing this? And, one of the reasons is just basic science, right? We don't really know much about the early stages of embryonic development, particularly in humans, because, through in vitro fertilization, you can create human embryos, but they have to be destroyed at the 10-day stage, maybe the 14-day stage. We don't really have the technology to keep these embryos alive much beyond 3 weeks. So there's really very little that we can learn, from human embryos, not to mention the ethical concerns, right? With those kinds of experiments. So the idea is that, hey, could we do something like this in mice that might provide us with an understanding? These are highly controlled systems, right? But the ultimate objective would be to be able to do this in humans, right? And the idea is that, well, if we're creating synthetic embryos, they're not technically embryos, and therefore they don't have the same ethical or moral
same status as being human.
Yes.
So
that's kind of the argument that's used, and we can kind of dissect.
That's debatable, right?
Right. We can. Well, I mean, this is where the ethical complexities come into play. That's. But part of the thinking is that if you can then create human embryos, not only can we understand, again, the early stages of human embryonic development, which may translate into understanding of why people are infertile, what causes spontaneous abortions. This is important insight to have medically, though the pathway to get that is, again, fraught with all kinds of ethical problems. But then on top of that, people are thinking, we would love to be able to one day grow organs, from stem cells. And going the organoid route is very complicated. Whereas if you could develop the organs through these synthetic embryos, you could have a source of organs
for example, there's papers that have been published saying that, hey, you can harvest stem cells at the time that a baby is born and store them and wait for the technology where those stem cells could be used to produce a kidney, where there'd be no problem if your kidney malfunction. You get one of your own kidneys. You don't need a donor. You get your own kidney, and you wouldn't have to take special drugs. But what you're suggesting is maybe a better way would be to harvest the stem cells at the fetal time of development in a way that doesn't harm the fetus.
Right.
But now you got stem cells that might be more useful.
Right. Well, the part of the problem here is I've not seen anybody use adult stem cells or any other source of stem cells in these experiments. I've not seen anybody use what are called induced pluripotent stem cells, which are stem cell-like cells. They've been focusing on embryonic stem cells, and there very well may be reasons that I'm not aware of that for that work. And this, or maybe later stages of the project will look for less ethically problematic cells. But either way, you're creating a synthetic embryo, right? And so there are reasons from a basic science standpoint, understanding drug interactions with the early embryo, which is very important when you're administering drugs during pregnancy. So there's legitimate reasons why people are trying to do this, but it's fraught with ethical issues. Now, the embryos at this point that have been developed are sometimes called blastoids, to distinguish them from blastulas, right? With the idea that they are not really the same quality as synthetic embryos, but people are going to try to get them closer and closer and closer in quality to human embryos or mouse embryos or monkey embryos, which we'll talk about in a minute, but because that's when they're going to become more valuable when you study them. If you're studying a crude facsimile of an embryo, what you learn there is questionable, right? And so once you start getting closer and closer to something that is a very close facsimile to an actual embryo, that becomes a problem. And this is the study that I wanted to talk about. This was again published just about a month ago from the Chinese Academy of Science, and they created an embryo, a synthetic embryo from a monkey, from a macaque. And the reason they did that is that this is a closer model to a human embryo.
Right.
So, and this, of course, again, as soon as this was published, the announcement came from the University of Cambridge about creating a human embryo. But this is essentially a summary of what they did. And they started again with these embryonic stem cells, and they turned them into these, what they call blastoids, which are synthetic. This is a synthetic blastula. And then they did a series of experiments to show that this is actually an embryo-like system. One is they re-isolated the cells from the inner cell mass, and they studied them to show that those inner cells the cells from the inner cell mass were behaving like an embryonic stem cell.
Mm-hmm.
Then they actually allowed it to undergo development through in vitro culturing techniques, and they showed that you get these structures that look like a gastrula. And then you can actually look at gene expression patterns, and those gene expression patterns match what an actual embryo would look like at those different stages of development. And then last, they actually took this synthetic embryo and implanted it in a surrogate, and actually showed.
That's where my eyes went. They actually put it in a surrogate
Yeah, and so
mother.
what ended up happening is a gestational sac formed, and then it ended up disappearing. So this is again reflecting the fact that this is still a crude facsimile of an embryo.
So it got rejected by the surrogate mother.
But the process of pregnancy was initiated and progressed to some degree. And again, the thought is, well, if we work on refining the culturing techniques, we actually may see a monkey being able to take this to full term, right? So the point is that you're getting closer and closer and closer to, something that looks like a bona fide embryo. And if we can work it out in monkeys, we're just steps away from applying that same technology to humans, which means people are going to make the argument that these synthetic embryos are like human embryos, but they're not technically human embryos, and so it's going to allow them to do all kinds of things. But for me, what is the moral status of these synthetic embryos, right, in humans, right? And the more they become like a human embryo, the less and less clear I am as to what the moral status actually is. So it feels to me like this is a place where we are overdriving our headlights in a really big way. Now, as a Christian, I'm obviously pro-science. I'm a scientist. I'm pro-technology. Generally speaking, I'm a technology optimist. I am a little concerned about the rate that technology is developing, but I do believe that there's bright people that are studying the ethical implications of this technology. I think increasingly scientists are becoming at least aware more and more of the ethical concerns. So as a rule of thumb, I'm optimistic about developing technology and more or less its appropriate use. But this is a place where I start to become, very uncomfortable.
Yeah, say you got a couple and they're infertile and they're wanting a baby. Would they be looking at this as a technique to get a baby? And if that's the case, where do the stem cells come from?
Right.
Do they come from the father or the mother? Do they come from the time when they were embryos or fetuses?
Right.
Or do they come from some other source that's got nothing to do with them?
Right. Yeah, to me, if you were a couple that was struggling to become pregnant, that there are probably better approaches that are much more, robust to,
without all these ethical issues.
Well, even with in vitro fertilization, it's not free of ethical issues because you are creating human embryos,
right?
And some of them are not going to be used. So, what do you do with them, right? But I think the motivation for these human synthetic embryos is to be able to experiment with them, to again understand, to understand embryonic development. So are we actually now experimenting on a human embryo, or is this something that is dangerously close to a human embryo, but technically not a human? I don't know, honestly, how to answer that question. And if you're now looking at this as a source for organ production or as a source for, a more sophisticated stem cells, one of the arguments I heard is that it's very cumbersome to take stem cells and try to culture them directly in the lab into these different cell types or into organoids for, possibly research purposes or organ transplant. But if you can create synthetic embryos, now the embryo is doing the work, and you're much more likely to get higher quality cell types, or maybe even to produce organs, or at least the beginnings of an organ that you could then harvest. And once you're dealing with stem cells, it's now scalable, right? Versus creating embryos through in vitro fertilization. You don't have to worry about donors, egg donors, and things like that. So there's very strong motivations, not so much for reproductive purposes, but I think for basic science, and then ultimately for
organ transplant.
Right. And so I'm very uncomfortable with this. When we look at scripture as a guide, it's very clear that as humans we've dominion over the earth, and I think that includes and dominion over life, and I think that includes justification for doing work in biotechnology and synthetic biology, provided we're not dealing with human systems. We've not been granted dominion over human life, only, but other life on the planet. So I don't have a problem with the work in mice or the work in monkeys. I don't see that as ethically problematic, other than concerns about animal cruelty, right? That has to be.
Well, Fuz, what about this proposal to raise pigs so that we can take their hearts and kidneys and livers and transplant them into human beings?
Well, once you get beyond kind of the ick factor, right? I don't see an ethical problem with that. There's probably a number of safety concerns. One is are we going to introduce porcine retroviruses and things like that into the human gene
pool? And will the human body reject the organ?
Well, it will. But there are ways you can modify the cell surfaces of the pig cells that are part of the organs so that it minimizes hyperacute rejection. So that is going to be an issue, but that's where genetic engineering and cloning could really go a long way towards developing.
Are you suggesting that might be a more productive and safer and less ethically problematic route than trying to go with these artificial embryo production?
Oh, yeah. I definitely do.
Okay.
Again, it's fraught with some very real technical challenges, but, there's to me, a big difference between, creating a supply of organs, using an animal model versus, again, using these synthetic human embryos.
And I'm guessing, too, that it might be technologically easier to work with pigs than to work with these artificial embryos, or is that not the case?
I don't know the answer to that one way or the other.
Right.
Like with the mouse embryo, it's easier to work with simply because the gestational period is shorter.
Right.
Right. And so the rate of development is greater, but the complexity of the animal that is being generated through that process isn't as great as what you see, let's say, for
a monkey.
Right? So, and which has a longer gestational period. So that means that there's a much slower rate of development, right? You brought up the idea of artificial wombs. This could also be a technology that could move us closer and closer to having the capacity for human reproduction to be exclusively within an in vitro situation. I mean, there's remarkable work happening on artificial wombs that are designed to incubate. This is all done with animals, but incubate the fetus if it's preterm, right? So there's a significant amount of the fetal development that's taking place in utero before you're transferring the fetus into an artificial womb.
Well, that has interesting medical applications. Like, for example, the mother runs into a crisis, say at 20 weeks.
Yeah.
And normally that baby wouldn't survive if it was taken from the mother.
Right.
But if there's a sophisticated artificial womb
Right.
that you can take from the mother 20 weeks, put it there, that might, actually push back the survival time of fetuses.
Well, I'm very excited about the prospects of artificial womb technology. For, as you mentioned, it not only will, extend the time in which a premature child can survive, but it probably means the outcome, is going to be better because it's a much more natural environment than being in an incubator.
Right.
And so there's some real positives to the artificial womb technology. And so not only do you get better outcomes, but you perhaps can extend the survival time for premature births, much earlier than 22 weeks or 21 weeks, which is what it is now.
Right.
So I see that as pro-life technology. But what's keeping the whole process from being done in vitro is that we only know how to really develop human embryos up to about the 14, 21 day stage, and that's where the process just kind of peters out. Well, now, people are looking at developing these artificial endometriums, that might extend that development further. This technology, by creating these synthetic embryos, means that you can then play around with survivability well beyond that 21-day or 14-day period of time, which means it's more and more likely that we'll have the technology to go from in vitro fertilization to birth, potentially all done in a clinical setting.
Because you've got two technologies. One technology saying, hey, we can help a fetus survive at an earlier time than 21 or 22 weeks. That technology is going to progress towards an earlier time of transfer.
Right.
Then you got the other thing saying, hey, we're moving forward beyond 14. What do they converge?
Right.
If they converge, then you actually have artificial womb technology, but that raises all the ethical issues.
Right.
What happens to a fetus that has no contact with his mother in the womb?
Yeah. Well, and when I wrote the book Humans 2.0, I have a section of the book on artificial womb technology.
Right.
To me, it's a great technology for medical intervention when you have to use it.
When you have to use, when there's a crisis.
But it's not it can't supplant what happens in utero. And there's a lot of studies showing that that interaction between the fetus and the mother has a huge impact.
Don't forget about us fathers. I mean, I was having a relationship with both of our sons before they came out of the womb. And, there's no really scientific evidence that has a significant effect, but it could.
Well, I mean, the developing fetus is actually interacting with the environment in the womb, right? And there are light cues that it's picking up. There are, sound cues that it's picking up. So there is something that is being contributed to the development, from the exterior environment. So it's not just simply the interaction that the developing fetus has with the mother.
Right.
Yeah. So anyway, these are challenging times, and I think it's very important for Christians, kind of the bottom line here, to really understand the technology, to really think through the ethical issues, and to be willing to engage, in the public debates about, how this technology should be used, because people are craving, input, in terms of how do we handle this ethically. And this actually is something that I would even think we may want to encourage young people in the church who are interested in biotechnology and biomedicine to consider developing expertise in these areas. It's walking a tightrope, to be certain, but if there's not Christians who are experts who represent salt and light, then we really are we're capitulating this very important area of biotechnology to essentially non-Christian influences.
And maybe we need to make the novel 1984 required reading again for high school students.
Right. And Brave New World and all kinds
Right.
of other things. Yeah. So anyway, that's all I've got to say.
Oh, that's really good, Fuz.
Yeah,
Thank
thanks
you.
you. All right. Well, welcome everybody, or not welcome, but thank you everybody for joining us today on Star Cells and God. We would invite you to put your comments about today's program in the comment section. We want to hear what you have to say about these two topics that we discussed. And then remember, go to our YouTube channel, subscribe. Reasons to Believe 1 is the channel. And then also make sure you use the notification symbol so that you are alerted when the next episode of Star Cells and God drops, which is every Thursday on our YouTube channel. And you can also get access to Star Cells and God on your favorite podcast app. So until next time, remember that the more we know about science, the more we have reasons to believe.